Morning, all the students. And here now we are going to discuss about Newton's third law of motion. Newton's third law of motion. Here, we already discussed about there is a third law initially. Every action is contain the reaction with the same magnitude, but opposite in the direction. Okay, clear? Every action is contain the reaction with the same magnitude, but opposite in the direction. Okay, that is only called what? Newton's third law. Okay, clear or not? Suppose when I am press this, I will come back. Okay, when I am pressed like this, okay, now who made it is actually this board. Okay, board is I am pressing the board, board is pressing me also. Okay, got it or not? Yes. How it is possible to stand on a press here? Okay, because of Newton's third law only, it is possible to stand on a sky. Sorry, it is possible to stand on air and water. Why? Why? Because we are giving somewhat of force on the water, but water is not given same force on us, equal to same force on us. Okay, clear or not? When there is a somewhat weight, what will be there? Okay, clear or not? At that particular place, especially fields, when we go for a fields, okay, when we are when we want to try to stand in that fields, okay, paddy fields, okay, now there is a totally it will be mud. Okay, when we are put our foot on that mud, okay, up to some time, up to some distance is traveling, afterwards it stops. Got it or yes? How? Why? Yeah, there is the mud is not given that much of force on us. Okay, now, but where the bottom it will be very hard. Okay, now at that time that is giving force on us. Okay, clear or not? Yes, every action is a contain same reaction but opposite in a magnitude with the same opposite in a direction with the same magnitude. Got it or not? That is only called Newton's third law. The statement of Newton's third law, very, very important. What is that? Every action contains a reaction with the same magnitude but opposite in the direction. This is called the Newton's third law. So many applications are there on Newton's third law. Okay, clear or not? Here there is a examples are there. Textbook there is so many examples are given here. Yes, and when there is a gun recoil, when the shot is a fire. Okay, one second. When there is in a movies, you may observe there is a gun. How they are, it will be working. Okay, clear or not? We are make the what actually when there is a bullet is a moves front, the gun will become back. Okay, clear or not? Yes, and as well as the rocket, especially yes, whatever the rocket in case of a jet airplane and a rocket, we are also used to the what actually this Newton's third law only. Generally, the rocket are nothing but okay, no, it will be given so much velocity gases. It will be touched with the earth, it will be moving. Okay, the rocket launching is a very, very important to the sky. Okay, clear or not? So many rockets are failure at the time of launching only. Why? Because sufficient force against the gravitational force is not a given. It will be not moves in a upward direction. Okay, clear or not? The rocket is a yes with the somewhat of force it will be kick the earth. Earth is kick the rocket. Okay, to the up direction. Rocket is gives the yes you know very well already you observed so many times in the news when the rocket is launching BSNL satellite today is launching like that news as you observed in that one what happened there is a lot of amount of the gases are and as well as whatever fuel burning things are it will be touched with the earth. Okay, got it or not? Yes, and automatically earth is give the force against to it. Okay, clear or not? That's why it is moving in a upward direction. Okay, got it or not? I hope you got it here. Yes, this is only about the yes rocket working. Okay, now in higher classes you have about a rocket. What is the working of rocket and how there is a Newton law involved in that. Okay, and next to come to here, swimming. You know very well all. Okay, when you are at the swimming, what you have to do? You have to what push the water in a backward direction. Okay, now you are moving in a front direction. When the swimming is going on like that, you have to make. Okay, clear or not? Otherwise, like that, you have to make. You have to go down. In case you have to make like this water, okay, you have to go down. When you are deep in the water, you have to move. What? Press the water downward. Okay, you are become upward. Okay, clear or not? One trick for you. When you dip in the water, you always press the water down with the force. Automatically, water is giving force on us. We are floated like this. Got it? Yes, and as well as we are make the what water is yes in this direction. We are moving in this direction. Okay, clear? Or not? A swimmer is thrown the water backward direction, and automatically the swimmer moves in a front direction. In which law based? Newton's third law based. The back direction. He given action in this direction, reaction in this direction. Okay, got it or not? Like so many things are there. How do we walk? Okay, how do we walk? Tell me. Yes, how do we walk? We walk at the time you are make the foot back. Okay, now you become front. Okay, now who made it? It's Earth made it actually. You are giving force on Earth backward direction. Earth is moving front direction. Okay, clear or not? Some members are want to walk in a backward direction also. Okay, at that time, what you have to move? You make it front. You are move the backward direction. Got it or not? Yeah, like that, there is a what everywhere. Okay, yes, there is everywhere action is a contain the reaction. So many are thinking about that when the sir is beating you with the hand, he is also get a pain because of your whatever the influential parts it is there, either speak or otherwise arrest, whatever may be. When we are beating you, okay, at that time there is your body part that is also beaten this particular form. Got it or not? Every action is a content. Reaction is the same magnitude but opposite in the direction. Got it or not? This is only called a Newton's third law. Okay, there is given two springs example. Actually, okay, now two spring balances examples are given here. Yeah, just a minute. Yeah, one second. This is only about our actually. Now, when you check it here, there is a I'm applied forces here. Okay, whatever forces are applied, when this is the giving force on me also. Okay, clear or not? Yes, in case another spring balance is also available with us, we'll get it. Okay, now, yes, when we are taken one spring is this side, one spring balance is applied this side, one spring balance is this side applied, the both are should compulsory every time become same one, but opposite in a direction. Okay, when I am applied here forces, the same equal to it indicate actually gravitational forces, or it will be measure the weight, not masses. Measure the weight. Okay, now clear or not? Yes, suppose I am applying my forces here, this much of force is applied. Okay, now there is the what actually 150 newtons I am applied here. Okay, clear or not? 1.5 Newton. Okay, now applied here force. There is it is indicated. Okay, yes. Now when I'm taken here, there is this small keychain like this. Okay, when we add like this here, it will be also giving force on it. It will be given somewhat of force or not. Okay, clear or not? Yes, like that. When I am removed here, it will be again comes to their original positions actually. Okay, got it or not? Yes, when I am applied here, it will be okay, give somewhat of force. The same force here, it is giving force in this direction. Okay, and it will be giving force in this direction. Okay, based on this one only, it will be working. Got it or not? Yes, now every action is a contain reaction with the same magnitude but opposite in the direction. This is only called what? Newton's third law. Got it? Next. Here, there is somewhat properties are given about the action and reaction. Both action and as well as the reactions are forces only. Yeah, all the students listen carefully. Here, both the actions and as well as the reactions, they are forces only. Okay, now yes, the word another synonym word for our force is action and as well as the reaction only here. The reaction and action, not another words, not any other words here. Is action and as well as the reactions are same words. Got it or not? Yes, and this is we are considered next afterwards here. We consider one more thing: action and reaction act simultaneously but different on different bodies. Suppose there is what we are considered. Okay, now yes, now I am taken here. I am pressing the board here. Okay, clear or not? Myself, I am action. Suppose this is become reaction. Action and reaction not containing one body. Okay, they are contained in another bodies, but they simultaneously work. They are not taken a what in a different instance. They are not working. Okay, clear or not? This there is a not working different instances. Okay, yes, and here there it is about actually working simultaneously. Yes, simultaneously. Understood or not, the students? Simultaneously it is working. Okay, got it or not? Yes, and here and action and reactions are what actually here? The action and reactions are forces. Okay, clear or not? No other physical quantity like a weight, like weight is also one type of force only, na? Gravitational force only, na? Like that, they are not other things. They are what actually? They are actually yes, what it is? Forces, and they are working in a different bodies. Okay, but simultaneously they are working. But action is in one direction, compulsory reaction is in opposite direction. Reaction is opposite direction. Reaction is opposite in direction. Yes, and as well as action and reactions are yes different bodies. And what is the meaning of it? They cancelled with each other. Okay, clear or not? Yes. And when there is the actions and reactions are imbalanced in mode, at that time only the bodies are moving. Otherwise, it is not moving. Understood my concept? Action and as well as the reaction, whatever there, they are working. Okay, now in a opposite mode, now when they are equal with one another, the body become yes stable. Okay, clear or not? The body become stable. When they are imbalanced, at that time only the body changes its nature. Okay, example is suppose I am already discussed type of the problem. Suppose Here we have taken 5 newtons. Here also 5 newtons. Okay, this is become action. This is become what? Reaction. Okay, clear or not all the students? This is become reaction. Now the total sum of resultant force F is equal to taken as 5 newtons. It is 5 newtons in the mind. Now it is become what? 0. Then the body is moving now. This body is called moving? No, it is not called moving. Okay, action is equal to reaction in case the magnitude is the same. Okay, now the body not called, it is in under moving position. When there is action is in reaction, magnitudes are become different. They are in a moving. Suppose it is in a 6 newtons. In which direction the body moves? In this direction only the body moves. Okay, here there is a rocket is a moving nothing but when it will be okay, yes, started. Before the starting, action is equal to reaction. Okay, clear or not? And how much reaction contained by the earth? Against to that, we are giving force by the mechanical engine. At that time, only rocket is moving. Here, you also contain one action force, and water is also contain another action force. Okay, clear or not? But both are when you are given a same force, water you and become stable in your positions. You want to move, you are giving a more force than the yes, water force. Okay, clear or not? Whatever the force is given by the water, that force is against that force. You have to give the force to the water. Okay, at that time only moving. This action and reaction says that how much force is required to move, how much force to stop it. Brake is applied. Okay, yes, brake is applied means what? Brake applied in a backward direction. Yes, vehicle is moving in a front direction. Okay, clear or not? And vehicle is a contained action. To the reaction of that action, we want to stop it. We should equal to that action. We are provide reaction. At that time only the vehicle stops. Okay, in this way there is a so much applications are there on by Newton's third law. Yes, you are bicycling. Okay, you are taken your bicycle, your pedal is a move front. Okay, now yes, the wheel is a moving in a backward direction. Got it or not? Yes, there is also Newton's third law is applicable. Got it or not? I hope you got it here. Everywhere in our whatever yes uh, general mechanics, everywhere there is action is a content, reaction with the same magnitude but opposite in the direction. Okay, got it or not? And as well as rowing a boat. Okay, rowing a boat, you know very well. Yes, boats are okay now. When they're rowing, what they are taking, like a swimming only. Okay, clear or not? Yes, they are moves in a front direction. Okay, now yes, like that back. Okay, the boat is moving now front. Okay, got it or not? They make the water back in direction. Okay, the our boat is moving a front direction. Got it or not? This is about action and as well as the reaction. Okay, and now wait. Next, conceptual worksheet. Let's one second here. In case of a jet, in case of a jet, aeroplanes and rockets. Okay, which law we are using? Third law we are using. Which law we are using? Third law we are using. Next, which law? Newton's third law. Second question. Action and reaction forces are. Action and reaction force are dash in a magnitude, but are dash in a direction. Same in a magnitude, opposite in a direction. Opposite in a direction. Got it or not? Yes, this is only the answer for it. And next, if a man jump out from a boat, the boat moves backward. This is due to what? Okay, clear or not? The man, yes, jumps out from a boat. The boat moves in a backward direction. It is because of what actually? Yes, it is because of inertia. Okay, got it or not? Yes, inertia only here. Okay. Yes, this is due to inertia. Actually, that out from a forward and a front direction. Either at the time it will be third law is applicable. Even question is somewhat a question mark based. But here, next fourth question. Yes, the question may like that it will be correct. If a man jumps front, okay, clear or not? Front, okay, that board moves backward, okay, that is third law. Okay, otherwise it is called as okay inertia only. Okay, and next year while flying, the bird pushes the air. Okay, na? Yes, downward. Okay, clear or not? Yes, when the flying is a downward, the bird is a moves. Okay, na? Up. Okay, clear or not? For a flying purpose. Okay, for a traveling purpose. Okay, back. Okay, for a flying only the given na. That's why downward. Direction is in which side? Down direction. Next, fifth one. Action and reaction forces are dash in a magnitude but dash in a direction. Already it's a given, no? Already it's the same third question. Okay. Next, level one. Swimming is possible by the Newton's third law. Okay. Sixth one. A man is at rest in the middle of a pond and a perfectly smooth ice. He can get himself to the shore by making a use Newton's again third law. Yes, a man is at the rest middle of a pond, perfectly smooth ice. Okay, he can get himself to the shore by making use the what Newton's third law. Is at the middle. You want to come to the bank. You want to move in a backward. That's all the whatever the shore ice shore shoes are there na, by using that. Next it is the what Newton's third law. Next second question. Sorry. The unit of force in an NKS system, so many times we are discussed it, that is the Newton. Okay, and as well as the time. Both are the answers only. Okay, clear or not? A and as well as the B. Single reason type questions only they given, but it is you use it too. Okay. Which of the following quantity is a frame independent? Okay, clear or not? Which of the following quantity is a frame independent? Yes, here velocity, force, displacement, and the kinetic energy. Here there is a kinetic energy is a frame independent. Okay, clear or not? All the vectors are contain the directions. Okay, they are depending on the frame. Actually, frame is nothing but what you know. Okay, frame is nothing but reference purpose. Whatever the observer you are taken, that is a totally called a frame. Frame of reference. It's a called actually frame of reference. Okay, the forces, which is the action, which is the reaction, which is the action, which is the reaction. How can you say we have to take a reference or not? For energy's purpose, not need not to take any reference. Energy is a what? Scalar, not a vector quantity. Okay, got it or not? Yeah. Now that it is the taken as a D. Swimming is a possible. Yeah, so many times the repeated questions are only there. Yeah, once check it, there is a The law which gives the properties of force, that is also the law which gives the properties of forces here. All it is actually, all are given the properties of forces. Na? Newton's first law, Newton's second law is also giving the properties of force. Okay, na? As the Newton's third law of motion is also. Yes, there is all are the actually. Okay, na? A, B, C. Okay, clear or not? Why? Because without that force, there is no Newton third law, Newton second law, and Newton first law. So unless until the force is not acting on the body not changes its position or it's a state. Okay, now yes, force is equal to okay now mass into acceleration or change of rate of momentum is called force applied on the body. Okay, now that is also given force formula, and action is equal to reaction. In case the force, the direction and magnitude, they mention the properties of force of magnitude and direction given by which one? That is Newton's law. Okay, clear? And next, among the following is the correct statement. Action and reaction are equal, hence they cancel each other. Action and reactions never acts on the same body. Angle between a action and reaction is zero. Force always does not exist in a pair. Yeah, there is all the last three are wrong. The correct statement is action and reactions are equal and they cancel each other. Okay, clear or not? Yes, now there is answer for seventh one is okay. Now, seventh one is yeah, A. Fifth one is A comma B comma. Yeah. Next there is a problems are there, numerical problem. Okay, 100 small balls each having the mass of 1 gram strikes on the surface having the area of 1 centimeter square normally, which the velocity of 100 meter per second and rebound back to the same velocity. The value of the pressure on the surface will be okay. Yes, and here the pressure is equal to, we have the till now we are not get any idea about the pressure in this class. Actually, in a 6th class only we have IIT foundation as a pressure. Pressure is nothing but force per area. Okay, pressure. Okay, pressure is equal to force per area. Okay, clear or not? Yeah, simply I'll give the one example based on your studies. Okay, here, okay, studies are this much only. Exam burden is this much. You feel a pressure or no? Yeah, that is only. Pressure is nothing but force per area. Okay, more force is required now for complete the thing. Okay, like that, there is a pressure is nothing but force per area. It is directly proportional to force, inversely proportional to area. Area is a less. Okay, na pressure is a greater. Area is a more. Pressure is a less. Okay, you know very well. When you are take a tap, okay, or otherwise any pipe of water, you want to take the water the long distance. What you have to make? You have to put your thumb in front of the water mouth. Okay, clear or not? Like this, it will be put. It will be moves the long distance. Otherwise, it will be fall here only. Got it? Or because of what we are decreasing area. That's why more pressure is available. Okay, got it? Or like that, that based on the pressure, one problem is there. Yes, our time completed, and tomorrow I'll consider that problem. This is only formula we have to use for it. First, we have to find force. Then next, there is given area. Then after, you have to find it what pressure. Okay.